Hi, welcome to the second video that goes along with session 5. We're talking about money today. Money, money, money. All right, let's turn to probably page 4 in your notes. And we are going to start with talking about present value. So let's look at that first problem. Okay, present value, let me just zoom in here, of an investment is the investment where no interest has been added. Okay, definitely want to highlight that. So we're going to do a problem that deals with present value. It says how much money should be invested in an account that earns 8% interest compounded quarterly in order to have $30,000 in 5 years. Well, here we go. Your ending amount, your goal is to have $30,000. N is 4. Your interest rate is 8%. Don't forget you've got to change that to a decimal. So you move the decimal 2 points to the right. And your time is 5 years. So we're going to plug it into our formula right here. Now here's where the algebra gets a little tricky. First, plug everything into your formula. I would do a few things here. 4 times 5 is 20. I'd clean that up. Now work within your parentheses. So you're going to go 1 plus 0.08 divided by 4 on your calculator. Hit equals. See if you get 1.02. If you don't, stop this video and play around with your calculator a little bit because that's what you should be getting. Okay, now you're trying to get p by itself, but we're multiplying right here. So to get p by itself, you have to divide both sides by this value, and that's what I'm showing right over here. So now these cancel. Sometimes people like to cross values out. Now in your calculator, do 30,000 divided by, I would use parentheses, 1.02. Hit your caret key. That's your exponent key. Looks like this. Okay. Tell your calculator that your exponent's 20 and then hit equals, and you should get $20,000. Okay? All right. Make sure you're rounding your answer to 2 decimal places. Let's try the next one. How much money should be invested in an account that earns 9% interest? Oh, can you imagine 9% right now? Compounded semi-annually. Now that's a buzzword. That means N equals 2. And your goal is to have $20,000 in 5 years. Okay, well A is always your ending amount, so our ending amount is 20,000. Semi-annually, there's our N equals 2. 9%, I've already moved that decimal over. Time is 5 years, okay? So we want to find out our P value, our present value. Okay, so plug it into the good old formula. Now again, just take your time. 5 times 2 is 10, so clean that up. And then work within your parentheses, please. Add these together. Oh, I skipped a few steps here. But you should get $12,878.55. So what you needed to do, figure out what this is, and then you want to divide both sides by this value. Okay? Okay. All right. Next section, section 6, is about inflation. I think we're all very familiar what inflation is. It's the loss of our purchasing power. Okay? Our money's not going as far as it did 10 years ago. And there's also an increase in the cost of things. I always think about candy bars. I remember buying a candy bar and they were 25 cents. And I think now they're like $1 and they're a lot smaller. And so that's an example of inflation. Or think about the movies. Do you remember in high school how much the movies were? And now it's like, who can take their family to the movies? It's ridiculous. It's like, what, $10 a pop? It's crazy. So there's some examples of inflation. Now we've got an inflation formula. It's right here. Okay, just got a little reminder here that R is a percentage rate. Now N would be any compounding. T is time in years. P is our beginning value, A is our ending value, or the value of P after time has passed, okay? All right, when you see the word annual in any story problems, annual means 1, okay? So let's look at this first problem here. Suppose your salary is $40,000 in 2010. Now there's an inflation rate of 7%. What salary do you need to earn, this is just 5 years later, in order to have the same purchasing power, okay? So we're starting with $4,000. 5 years passes. Here's our inflation rate. Move that decimal 2 spots to the left. There's that word annual. So n equals 1. So we're trying to find our ending value, okay? All right, and what you might want to do, you could maybe even label this. You could say A is your purchasing power after time has gone by, something like that. So again, we're just using that same formula that we use in our other examples. Plug and chug. 1 times 5 is 5. Work within your parentheses first, so you have 1.07. So let's put that in your calculator right now. 1.07, let's raise it to the 5th power. And I'll do that also. Okay. And then let's multiply it by 40,000. All right, now you only need 2 decimals. Now be careful here, ladies and gentlemen. I hope you can see the values here. I've got 0.069. Well, that 9 rounds the 6 up to a 7. So make sure that you don't write 0.06 here. We've got to be really careful with our rounding. Okay, next problem. This is a little different. For those of you who are thinking about retirement, this might be kind of a shocking problem to you. So let's take a peek here. You purchase an insurance policy in the year 2010 that will provide you with $250,000 when you retire in 25 years. Assuming an annual inflation rate of 8%, what will be the purchasing power of the $250,000 in 2035? Well, 25 years has gone by. Here's your 8%, okay? Your ending value, so after this 25 years has gone by, this is your ending amount, okay? We've got n equals 1. The reason is this buzzword right here of annual. And we need to figure out our p-value. So plugging everything in looks like this. Okay, now 1 times 25 is 25. Work within your parentheses. Okay, now right now we're multiplying p by this stuff. So if we want to get p by itself, we have to divide both sides of our equal sign by whatever 1.08 to the 25th is. And there we go. So $36,504.48, okay? So what that means is, you know, here you're thinking, wow, in 25 years I'm gonna have a $250,000. Well, yeah, but it's only gonna really be worth $36,000. You know, that's scary. That's very, very frightening. It kind of is changing the way I look at investing for my future. Okay, now we're going to switch gears a little bit. You can read this on your own. I'm going to show you how to find effective interest rates. It's a 3-step problem. The first thing you're going to do is you're going to find your A value, then your I value, and I stands for interest, and then you're just going to tack on a % symbol, okay? So let's look at this next problem. A bank offers a certificate of deposit at an annual, okay, annual, think about what annual means, at an annual interest rate of 4% compounded quarterly. Okay, now quarterly, that's your n value. Find the effective rate. Round to the nearest 100th of a %. Okay, All right. Now, what I did here, we weren't given a value of what we were depositing, so I'm just going to say, hey, we're going to put $100 in the bank, okay? And we left it in there for 1 year, okay? Compounded quarterly, and our R value right here is 4%. Now, what we're going to do is we're going to take these values, let's plug them in here. I'll just show you all those steps here. All right, you've got to find A first, okay? So you're plugging all your values in, and we have this. Okay, now step 2. You're going to use your equation for interest that I equals A minus P, okay? All right, now we have our I value right here. We're going to subtract our P value right here. So we get 4.06. And then step 3, just tack on a percent symbol. Pretty easy, okay? All right, now I want you to know there's another way of doing that type of problem. I'm going to show you 2 different ways. I don't care which way you use, okay? Use the way that made sense to you, okay? Personally, I think this equation's faster. It's not in the book. But if you don't like this equation, then don't use it, okay? All right. So here's another way of doing that same problem. We knew our R value, we knew our N value. I just plugged them in. I put this in my computer or my calculator first, raised it to the 4th, I subtracted 1, multiplied by 100, and boom, I got my answer. There's no steps in this. You just plug everything in once, put it in your calculator, hit equals, and you're done. To me, I like this. I don't like having to think about step 1, step 2, step 3, but if you like the other way, go for it, okay? All right, I want you to open up your books to page 672. We're going to look at problem number 62, and it's asking you to calculate the effective annual rate, okay? All right, so I'm going to do it this way. All right, if you want to use the previous example and use this 3-step process, have at it. Okay, so in this problem, you probably should just stop the video because you're going to need all your values. So let's do that. Shut me down. Bye. Okay, you read the problem. The interest rate was given to you. We had compounded quarterly, so our N was 4. I'm plugging everything in. I've got the R value, the N value. Okay, and I'm done. 8.67%. Okay, those are pretty easy. Now we're also going to have to find the annual yield. The annual yield, ladies and gentlemen, refers to earnings or the yield you earn on a deposit over a year. And it does take compounding into account. And it tells you how much you are making on your money. Okay? Now, in this formula, the formula that we've been using, this part right here is the formula for annual yield. You don't look at the P and you don't look at the A, okay? It's right here. If time is not given, you assume that they're talking about 1 year, okay? Okay, let's look at this next problem. This is from your book. It's page 672, number 88. It says, which investment has the higher annual yield? One earning 7.8% compounded monthly, now right there, N equals 12, or one earning 7.5% compounded daily. Now don't forget, if something's compounded daily, N is 360. Okay, now I want you to be careful. Don't go crazy when you round your values, because sometimes on these problems you're going to have to look at the 4th or 5th decimal. And if you round right away to 1 decimal or 2 decimals, you're going to think, oh, these values are the same. So be careful. They're not the same. So let's plug and chug here. Investment number 1, my R value is right here. Quarterly is 12. I plugged my R and my N right here, plugged them into this, and I got 1.0808. Took investment 2 and I got 1.0778. Now I will tell you, I've had students in the past say, well, they're equal, because they take this 7 and they round this to an 8 and they go, oh, they're both 1.08, and they're not. So be careful. This one's larger, okay? So watch your rounding. All right. Credit cards, okay. People forget that when they put anything on a credit card, a loan is created. You are borrowing from a credit card company, folks, and don't forget that. You're going to owe someone some interest. Finance charges are involved, okay? There's due dates. You can't just pay your bill whenever you want. Usually the due dates are 1 month after the billing date, okay? Usually about 30 days apart here, okay? The average daily balance is used when determining the finance charges, and I'm going to show you how to find the ADB. Okay, we've got a nice little formula here. The average daily balance is found by doing this. You take the sum, now that means you're going to add. You're going to take the sum of the total amounts owed each day, and you're going to divide that by the number of days in a billing period, okay? Okay, first of all, we're going to take some baby steps here. We're going to do a problem which is fairly easy, and then we're going to do a credit card problem which is fairly intense, okay? This is example number 3 on page 686, and it says calculate the finance charge, and I'm just reminding you that finance charge is interest. Calculate the finance charge for a credit card that has an average daily balance of $10,154.87 and an interest rate of 1.5%. Now, here's where you have to switch gears. On the last video and on this video today, you keep hearing me say, time is in years. Well, when you're working with a credit card, time is in months. So I want you to change your thought process right now on time. I would even highlight this, please. All right, time is in months. Now in this situation, you're only focusing on 1 month, okay? So we're going to use interest equals principal times rate times time. I'm going to show you how this works. Your principal is your balance on your credit card. Here's our interest rate. Our time now is 1 month. Multiply those together, and you are going to get, let's see here, 10,154.87 times 0.015. I got $152.32. Woo, that's a lot in interest, folks. So keep those credit cards low. You know, it's a lot of money. Okay. Now what we're going to do is we're going to calculate the average daily balance and monthly interest on a credit card. So I need you to look at page 686, please. 686, number 5. So please turn the video off. I want you to read that problem about 2 or 3 times. There's a lot to take in. Okay, now on your notes here, I've got a nice chart, and it has 5 columns, and I'm going to show you how to fill in those columns to make this credit card problem fairly simple, okay? Okay, first thing that you want to do is you want to fill in your dates, and that's column 1. So I want you to fill in the 3 dates, and I want you to put them in order, okay? So please do that. Okay. Step 2, I want you to figure out the days since. Okay, now what in the world do I mean by days since? Here's what you're going to do. How many days go by between the 5th of March and the 12th? Well, 12 minus 5 is 7. And how many days pass between the 12th and the 28th of March? Well, 28 minus 12 is 16. All right, now you got to be careful on this last one. how many days passed between March 28th and April 5th? Well, let's look at this calendar that I've got right here. Okay, so March 28th to the 5th. So 1, 2, 3, 4, 5, 6, 7, 8 days. 8 days go by, okay? So 1, 2, 3, 4, 5, 6, 7, 8. So right here is where the 8 comes from, okay? All right. These values now go, and kind of going a little ahead of myself here. They go right here, 7, 16, and 8. Okay? Now step 3, fill in the payment or the purchase columns. Okay, well you made a purchase on the 12th. Now if you make a purchase, your credit card goes up in value, right? So you have to put a plus here. Then on the 28th you made a payment of $100. So now your balance decreases. So I put a minus here. So what I might do, especially if you work in a bank, I've noticed that students that work in a bank, they get these two values mixed up, the plus and the minus, because they're looking at it as the bank. Okay, so be careful, don't do that. So I would write myself a note. If you've made a purchase, you're going to be adding, so let's write that down. And if you are going to make a payment, you're going to be subtracting, okay? Okay, so right now on your chart, you've got your dates, you've got your payments, and you've got this days since. Okay, now step 4, it says figure out the new balance, which is column 3. Okay, here's what you do. In this problem, it said that we started on the 5th with a balance of 244. That's where I got this value. Now to get this value, I go 244 plus 152, and that gives me the 396. And then 396 minus 100 is 296. Okay? All right, now step 5. Take your balance and multiply it by your days since. So you're going to multiply these, and that's where I'm getting this column. Step 6, add up your unpaid balance column. So now add these up, and you'll get 10,412. Okay. All right, now step 8, find your finance charge. Okay. So now you're going to have to do your interest equals PRT. Okay, so do that. Oopsie, know what I forgot? Right here, I'm rambling and we've got to do this, our average daily balance. So let's take the sum, here it is, divided by the number of days, okay, that we had in March. Now be careful, depending upon the month, this could change, okay? And we've got this. Okay. All right. Now what you can do, let me just read the problem over again here because I've been concentrating on all the math part. Let's see here. Find the average daily balance. Oh, you know what? We don't even have to do this. I thought we had to do more. The book says just find your average daily balance. And we did. We are done. Okay. Now, here's what I'd like you to do. I want you to stop this video. I want you to try the next problem. It's a credit card problem. It's found on page 676, progress number 1. Go slow, fill out your chart, follow the steps, and see how you do. Okay, so please shut the video off, because if you just start copying from me, it'll seem easy. But it's a whole nother ball game when you try this yourself, okay? All right, so turn me off. Bye-bye. Okay, let's take a peek. How'd you do? Your ADB is right here. Now, if you're totally off, I know what happened. You probably didn't have 10 right here. Okay, so be careful here, okay? All right, because from the 22nd to August 1st, 10 days go by. So get out a calendar, you know, look at a calendar, okay? All right. Take a peek, make sure all these are right, and you multiply. Okay, now this one on page 676, to get the interest, you had to find your ADB, okay, and then that's your principal. That's how much you've got on your card. No, I'm sorry, that's not how much you have on your card. I apologize. That is just your principal value when you use I equals PRT. So you plug that in, you multiply it by your rate. Now be careful here, it's 1 month. Just do one, don't do 1 out of 12. Sometimes people want to put 1 out of 12 here because they're thinking years. Don't do that. Put this in your calculator, and here's your answer. Okay? All right. Well, I'm going to stop there. I'm kind of brain dead, and I'm thinking you probably are too. The next thing we're going to talk about for the next video will be consumer loans, okay? Consumer loans. All right, bye-bye.